So I'm going to do, Ryan, I'm going to do a quick review of some trig and factor stuff. I'm going to break them up because they each have a All right, guys. Sorry. In the middle of something, finish it up. We got to do some math. It's kind of funny, on the first day I always think about that scene from Jurassic Park. You guys have seen Jurassic Park? Jeff Goldblum says, are there going to be any dinosaurs? And they say, like, is there going to be math in this math lesson? So guys, I'm going to...
Everybody, do that register.
I'm going to do a quick little something about factoring and trig. Two crazy important things in both Calc 1 and Calc 2. And then I'm going to break people up based on their courses. Because I have a handout for a 180, kind of like a prerequisite warm-up handout, and one for 280. So, let me ask you this, very off the cuff, kind of out of nowhere. Can anyone tell me anything besides what you see on the screen there about trigonometry? Give me one fact about trig.
Unit circle exists.
Unit circle exists. Yes?
It's about units. No, it's about ratios of triangles.
I love it. Kick ass. All of trigonometry is based on all the ratios of such sides of right triangles that you can create. Never forget that. How much do we do with trig?
A lot.
Stupid amount, but it always comes back to, it's fundamentally defined as the ratio of certain sides of a right triangle. Whoop-de-doo, and then we just do all this insane stuff with it, you know. Especially when you start getting into law of sines, law of cosines. Does this sound familiar?
Yeah,
I saw that some people in the back just have traumatic flashbacks. Sorry. So let's do this. Just a couple of real basic things. Let me show over this here. There we go. Okay. So can somebody just tell me what the sine of 60 degrees is? All right, so I got to vote for 1/2. This doesn't mean it's right. One vote for 1/2. Anybody else think it's 1/2? Yes? I think it's 1. Neat.
Square root 3 over 2.
I got 2 votes for rad 3 over 2. 3 pi over 2? So what? Okay. So, let me ask you guys this. I have this feeling that a lot of you, I want to be very sensitive here. Did you learn SOHCAHTOA?
Yeah.
Okay. What I need you to understand, I really need you to understand, SOHCAHTOA helps you this much. What helps you the most, where are my trig students? Sine is
Why?
y. So it's y over hypotenuse. Cosine is
X.
x over y. So the sine goes like the y side, and the cosine goes like the x side.
Yeah.
So 60 degrees, is it closer to the x-axis or the y-axis?
Closer to Y.
So the thing that likes y should be bigger, yes?
Yes.
Sine is biggest at 90 degrees because then it's all frickin' y. So sine of 90 is 1. Sine of 60 degrees is less than 1, but not crazy. It gets smaller and smaller and smaller, yes? So let's say this is the y piece, yes? If I go up here, isn't the y piece now much bigger? So if sine is based on the y side of the right triangle, as I move up that y piece gets bigger and bigger and bigger, then it should grow. So 60 degrees is pretty close to the biggest, so it should be the bigger output, root 3 over 2. When is sine going to be 1/2?
30.
30 degrees, because then it's really close to where it hates it. It's a little tiny y, look at that little tiny y piece. Right, so that's 1/2 versus rad 3 over 2. You guys kind of with me?
Yeah.
So this is why when I teach trig, and I know a lot of my students in that class have heard SOHCAHTOA before, I try to get them to let go of that a bit because it helps with one kind of problem. Whereas if you just remember sine likes y, cosine likes x, it helps with everything. Maybe. Okay. So this is rad 3 over 2. What is tangent of 45 degrees? Yeah, why? Because tangent is what over what?
Sine.
Sine over cosine. Kick-ass. Okay, so I'm not going to do a ton of this. I just want to shake out some of the rust. How would you evaluate, one more, how would you evaluate secant of what, Jeff? 225 degrees. Yeah, good. I see somebody drawing in the air. So it's not a bad idea to find the what? Reference angle, kick-ass, because you always want to reference it to the first quadrant, yes? Because you memorize trig stuff in the first quadrant. Bless you. All the other quadrants have the same number, just a different SIGN. When you start to teach trig, you got to spell the freaking sign. All right. So 225 is where?
It's like in the third.
Yeah, because this is 180, and how far did it go past 180?
40.
45 degrees, so that's my reference angle. Reference angle is just how much you overshot or undershot the x-axis. That's all a reference angle is. Because then you've effectively put it in the first quadrant. Now, can somebody tell me if this is going to be a positive or negative answer? Because what's secant based on? It's 1 over
The next.
cosine. It's the reciprocal of cosine, yes? I love it. So S goes to C, C goes to S. Cosecant sine, secant cosine. I like it. You know, so many guys are like, dude, first day. But I need to shake some of this out. Trig is huge, especially in 280, but 180 you're going to get trig too. Let me see. Keep myself from dying. It's always a good goal. So let's continue here. So 45 degrees. You guys told me it's going to be negative, which I appreciate because x is definitely negative. And this is 1 over the cosine, and the reference angle is 45 degrees. So this is a very, oh, that's funny for me. Look the way I did it. This is smart. No, but this is a smart way to do this because now you can just focus on this. What's the cosine of 45 degrees?
Root 2 over 2?
Root 2 over 2. What do I do with that business?
Gotta flip,
Oh, you got
rationalize it.
Now real quick, what is 2, what's a whole 2 divided by half of 2? What's a whole 2 divided by half of 2?
1. Wait. Undefined.
It's half of 2, yes. What's a whole 2 divided by half of 2
2.
multiplicatively is the other half of 2.
Yes. it's
Now
two
if you rationalize this silly thing, let's do it the long ass way.
Well, if it's divided by half of 2, it's divided by 1, which is itself.
-2.
You finally get to,
Over
oops,
2.
what did I do here? I did
It's
it correctly.
-2.
Go Jeff,
No,
go
there
Jeff.
you go.
Okay. Negative rad 2. I was thinking I was going to square it, but I didn't do that. Okay. Does this sort of come back to you?
Yeah.
Not at all? I'm sorry. Is that too fast? Shit. I'm going a little fast because the little handouts I'm going to give you are going to focus more on certain things. Beyond this are the identities. What's the most basic trig identity? Who remembers that? Yeah, the Pythagorean identities. And the most basic one of those is sine squared plus cosine squared equals 1. And then let me be very careful. Sine squared theta plus cosine squared theta equals 1. One of the biggest mistakes I see for any student dealing with trig is you guys forget that
Plug those.
this doesn't make any sense. It's got to be of something. So can anyone see the difference between these two functions?
Yes.
Sine has tangent in it. So tangent's inside of sine here, whereas this is tangent x times sine x. Are you with me? Some of you guys who have taken Calc 1 understand that these will have very different approaches if I ask you to do the derivative. Those of you in 180 are like, what the shit is that? Don't worry. This is going to be the weird thing about this class. It's, different levels. Okay. So be very careful about reminding yourself that this does not make any sense unless something's in it. It's like me saying, can you guys simplify this for me? What would your question be?
What am I saying?
Huh?
What are we doing?
Square root of what? Yeah, exactly. So if you just write this, sine of what? It doesn't make any sense. Okay. I like it. Or are you accusing me of something? I don't know. Okay. And now, real quick. And again, we got a little worksheet, so I don't want to spend a lot of time lecture. You get enough of that from whoever the hell your teacher is, and I know it's me sometimes. Can you guys take a moment and try to factor? What do you got to do, Jeff? You actually have to have a problem. That would be good. There. Would you guys say this is a relatively easy or a hard problem?
Easy.
The key word there, the word that does a lot of the heavy lifting, is relatively. Could factoring get worse than this?
Yes.
Hell yeah. I do want to do one specific type that I didn't put on here. Yeah, I forgot to do that. That's okay. What is the question here really boil down to? What is it that you actually have to do the work for?
To figure out.
Good. Add to be negative 6.
And then
Multiply to be negative 16. I love it. Does anything work? Did Jeff make a good problem?
2 and 8.
Holy shit.
2 and negative.
2 and 8, and the bigger one's negative. I love it. How are we doing out there? Now again, another thing about any class I teach is I have certain people in here that took the last math course 6 years ago, and I have certain people in here that took the last math course over the summer. So I mean, some of you guys have a little more deep digging to go for to get the answer sometimes. So I understand that. If I ever do anything in this class that I'm going a little too fast over, just tell me to slow down. If I'm going too fast, slow me down. If I'm going too slow, deal with it. That's my standard thing. So x times x is x squared. That's big. That's ground shaking. And then we just figured out that negative 8 and plus 2 make the numbers work. Okay, so that's old news. How do I do this? I'll say that's 1. Oh shit. Why is this one worse?
you guys back to 4 out.
Stupid 4 out front. What the hell, Jeff?
4 out, and then back to the rest of it. And then
Can I take a 4 out?
No.
Because will a 4 come out at 5 and 6? Not nicely.
So
You
negative
could,
5.
but then you have fractions to work with. I'd really rather not. Yes?
In Calc 2, would completing square be needed?
Positive 6 and negative 1.
No. Let me think. Well, there's a couple situations, yes. In Calc 2, there are some integrals you might have to do. To put it in the right form, you might have to complete the square.
Yes,
Yes.
that is a thing.
So just to let the 280 students out there know, completing the square will become a thing. Again, it will rise up from the dead. Right? And I'll walk around it.
It's not common, but you will see it.
Yes. It will have its place, once again. Will it be prominent? No. Will it be useful sometimes? Yes.
Yes.
Okay, who can tell me what do I do first on this problem?
Regroup?
Yes, multiply these together. So very quickly, don't even write this down. Just watch this. I want to show you a little motivation. If I do x plus 2x minus 8, some of you guys might realize what this is. I'll get x squared plus 2x minus 8x minus 16, yes? And how do I make the middle term? The middle term is exactly these numbers put together, yes?
Yes.
That's why when there's a 1 out front, I just have to find the 2 numbers that make those 2 things happen. The minute I put some shit out in front of either one of these guys, I'll get 8x squared plus 10x minus 12x minus 15. So I get 8x squared minus 2x minus 15. Is negative 2 negative 3 plus 5?
Yes.
Negative 3 plus 5. Is that equal to negative 2?
No.
I love you guys so much. No, of course not. I picked one where it just happened to be the same number. That kind of sucked, but too bad for me.
It's positive 2.
Exactly. So I can't get these numbers by looking at this and making them add to be this. Are you guys kind of with me?
Yeah.
Of course, I made one up totally out of nowhere that just happened to be close, but that's coincidence. Stay with me now. This is kind of cool. Help me out. What is 8 times 15? Real quick, how do I do them in my head? 8 times 15 is 4 times 2 times 15 is 4 times 30. What's 4 times 30? 120. What's 10 times 12?
120.
120.
So you.
With me? So what I do, these numbers are here because of the influence of these factors of 8. You guys kind of with me? So I really want to, I'm not going to spend a ton of time on this, but I want to give you a little clue as to why the process makes sense. I have got to take into account the fact that the factors of this stupid thing are going to mess my middle term up. And we see it right here. The fact 2 and 4 messed with my 3 and my 5 and screwed up my middle term. So the very first thing, and I think somebody just told me this, is you multiply 4 and negative 6. The really nice thing about this process is you immediately do exactly what you did before, just with that new number. What multiplies to be negative 24 adds to be negative 5. 8 and 3. And which one's got to be negative? The bigger one. To make you owe money in the end, right? Oh, $8, no, blah, blah, blah. Does anyone know this process? Does this look familiar? What will I do next? Good. I'm going to break the middle term up using those coefficients. And what is the beauty of doing that? How many terms do I have now? 4 freaking terms, so I can group. And grouping is relatively easy, yes? Now, I'm hoping some of you guys have maybe kind of developed your own way to do this. Once you get to 180, 280, I'm sort of like factor whatever the shit way you determine is the best. I mean, that's what I call making math your own. And I try to make room for that, especially when you get higher level mathematics. You should have made some math your own. You want me to show you how I do this problem?
Yeah.
Okay. I don't do this shit. So when I have this problem, by the way, is everybody cool with finishing this out? Real quick, you can take a 4x out of here, x minus 2. Take a 3, x minus 2. You know they're in the right track because those are the same. Since they're the same, they come out. So you get there, blah, blah, blah. Okay, now, here's what I did, real quick. And then I'm going to finally shut up and let you guys work on something. What was the problem again, Jeff? Oh, yeah, 4x squared, 5x minus 6. I do something that's got the unfortunate name of Texas slide. Sounds like country line dancing, but I'm not a big fan of country, so if you like it, sure, why not? So here's what I do. This is all work in the middle. I solve this question instead. So I've slid the 4 over to the end. So then this question is easy, yes? X minus 8x plus 3, yeah?
You do that all the time.
Now, I can't stop here, can I? Is that the answer to the original question?
No.
It's the answer to this question. So here's what I do. I slid a factor of 4 from the front to the back. So now I'm going to slide a factor of 4 back. Do you all agree with me if I multiply these together I get negative 8x?
Yes.
If I slide a factor of 4 over here, don't I still get negative 8x? Do you guys see that? Don't I still get negative 8x? Are you all with me? Okay. Now, you do not have to do it this way. Holy shit. You with me? But that's the way I do it. It's just quicker. Now, you have to feel really comfortable messing with your numbers, but it will still work. Okay. All right. So, what I want to do, and my 280 people, I want to tell you something. When I discuss topics that work for Calc 1, I can basically talk to everybody. If I want to discuss topics like integration and differentiation, I'm going to have you broken out. Because again, roughly half of us don't know what that is yet, officially. Okay. So what I want to do, let's see if I can do this. Well, let me do this first. Will my 180 students please raise your hand? And let me give you your correct handouts. It should say $2.99 at the top, but don't worry, that's what it used to be, so that's my fault. Shit, well, enough. Probably not enough. You? Yes. Shit. You guys? Oh, crap. All right, I'm gonna have to print more. Is there anybody here that I didn't call your name? How is this possible? Okay. Is there anybody? I'm gonna have to figure you guys. All right, my 280 students, raise your hand. My 180 students, did they get a handout? I'm gonna go print you out one. Don't worry. Lower your hand. 280 students only. Okay. So I'm gonna sort this out right now. 280. 280. So yeah.
Okay.
All right. All right, my 180 guys who didn't get one, I'm